Those are my 3 words.
Oh.
And by the way, those 3 words, if you put them into Google, do not come up with your location.
Yeah, you got to go into the what 3-word site, I think. Did it really generate I am here?
No, but when they ask, what's your location? I'm here.
No, I get it. I'm a little thick tonight. It's been a long day.
For all of us, and there's been so many Zoom meetings today, it's been unreal.
Yeah, I think I've been on it all day. It does get fatiguing. Was Jerry going to be with us tonight?
Yeah, I'm here.
Oh, hi.
I was just trying to change my screen.
We can see every pore. You're zoomed in so tight.
Just pretty much. And we got a couple minutes, so wait.
I was on a meeting this afternoon, and one of the people had a new Surface computer they were using, and they were upside down. They couldn't figure out how to get themselves
Oh, really?
from being upside down.
Yeah. Okay, I got it over like I usually set it now. So. Well, it looks like it's 7 o'clock, so we'll get rolling here. Well, thanks everybody for checking in. I got in a little late on the. Looks like some interesting stuff there on the when I brought the screen up. So that's good, Jerome. You're coming up with a lot of good stuff. Welcome everybody. I'm Jerry Vilhauer, W0GV, the DRC club president. Welcome to. I think it's month 9 or so. Who's counting of this virtual stuff? But like I say, it is what it is. So we're dealing with it, and everybody out there is too, I guess. But it's kind of becoming a new way of life, it seems like. But maybe things will turn around here one of these days. I don't think I've got anything club-wise to bring up unless someone has a question that I can maybe answer related to the club. Looks like we've got 37 people checked in now, and that's good. Anyway, anything for me at all that I could possibly answer? I think all the systems are working now, as far as I know. Like I say, any of you that are 6-meter people were working on a remote receiver for the 6-meter repeater, and that will hopefully do a lot for the receive, obviously on the 6-meter, because we're over in a fairly noisy part of town, electric wise. So this is going to be a quieter site, and we'll remote the receive into the transmitter from our over our microwave. So we're looking forward to doing that. I think I've got all the parts gathered up pretty much. So we're proceeding at lightning speed here, you know. So anyway, I don't hear anybody say anything question wise, so we'll start the program with Matt Webb, the Western U.S. coordinator for Motus Wildlife Tracking. And I heard you talking a bit earlier when I came on, Matt, so I never had a chance to meet you, but welcome. Thanks for taking your time to do this for us. And with that, I'll shut up and it's all yours. Go right ahead.
All right. Well, thank you very much, Jerry. That's great to be here. Great to be with the club. I'm going to try to share my screen real quick, and we'll see how this all ends up working. All right. Can you see my screen now?
Looks good.
Yeah, see
Okay.
it.
Sounds like a classic question of 2020. Can you see my screen, or am I on mute still? Those are things we hear often, almost every day. So yeah, I'm not a radio expert by any means, and this job and this project in particular have really opened up my interest in radio, and it was great to sit through that Elmer session and learn more about what people do and what kinds of things people are interested in with radio. So I'll just jump into the project here, and I want to leave a little bit of time at the end for questions and things, and I'll do my best to answer the questions as they come in. So my name is Matt Webb. I work for Bird Conservancy of the Rockies. I want to tell you about a project we've got going on developing a Motus Wildlife Tracking Network in the Great Plains and Chihuahuan Desert. This work is heavily supported by the U.S. Fish and Wildlife Service, as well as Birds Canada, a nonprofit based in Ontario. And Birds Canada are the home base for the Motus Wildlife Tracking Network. They pay part of my salary as well. So, yeah. Like I said, I work for Bird Conservancy of the Rockies. Our mission at the organization is to conserve birds and their habitats through a three-pronged approach of science, stewardship, and education. And we're based here in Colorado, but we work throughout the region, really the central half of the country, from the Rockies to the Great Plains and down into Mexico. And much of our work focuses on grassland birds. So grassland birds have been experiencing some extremely steep population declines. There's a paper that came out just this last year showing that we've lost over half of the grassland birds that existed just 50 years ago. So in early 70s, there were twice as many grassland birds. And those declines are due to a number of things, all of which we're trying to get at, trying to learn more about, and trying to reverse. So I'm playing the call of a Baird sparrow right now. I don't know if my audio is coming through or not. Somebody can tell me if they can hear it. But the Baird sparrow is one of the birds that's experiencing some of these steep declines.
And we're not hearing it, Matt.
Okay, I put that in there because later on I've got a little bit of audio, but if it doesn't come through, that's not a big deal. We can talk about what you might be hearing. So at Bird Conservancy, we're trying to understand the causes of grassland bird declines, and understanding these are extremely complex. It involves multiple components of the species' annual cycle, what they're doing throughout their year, and also involves work that spans multiple continents. As you can see from the range map of the Baird sparrow here, they breed up into Canada and they spend their winters down into Mexico. And so it's really a tri-national project trying to work on the conservation of grassland birds. The majority of the grassland birds that we have here in the United States breed in the northern Great Plains and then spend their winters in the Chihuahuan Desert, which is the southern half of this central part of the United States and extends down into Mexico. A couple of years ago, U.S. Fish and Wildlife Service and numerous partners put out this full annual cycle conservation strategy for 4 specifically hard-hit grassland birds. And migration was identified as one of the biggest gaps in our knowledge of grassland bird ecology. What are these birds doing during migration? Where are they going? What routes are they using? What areas are they using as stopover sites? And Motus itself, Motus Wildlife Tracking System, was specifically identified as a technology that might be used to fill in some of these key gaps in knowledge. So the Motus Wildlife Tracking System is essentially an automated radio telemetry station network that is coupled with tagged animals. Birds and other animals are outfitted with radio transmitter tags that transmit at 2 different frequencies. There are 2 manufacturers of tags, and each of those manufacturers have their own frequency that they use. And when one of these tagged individuals passes near to one of these stations, a detection is logged. And when those detections are combined together with multiple detections from one station or multiple stations, we can learn about routes that these birds are using during their migratory movements, as well as some in-season, breeding season or wintering season movement behavior that they might exhibit. So we'll kind of get down into what a station looks like. Motus Wildlife Tracking System consists of 2 components: the station itself, the receiving station, and the tags that are placed on animals. So the station is fairly simple. It is a computer. There's 3 different kinds of computers that you can use right now for Motus receivers. A sensor station, which is a Raspberry Pi based system shown over here on the right, purchased from a company called Cellular Tracking Technologies. This one is kind of what everybody is moving towards using right now, simply because it's everything you need all on one board. They've really made things simple for us. Low tech wireless. They make some of the tags. They also have a receiver that you can purchase from them. And then you can build your own receiver, what's called a sensor gnome, and it's simply a Raspberry Pi based system built of combining a bunch of consumer electronic components that you can purchase online. Within these station computers, we use the software-defined radio dongles. The ones that most everybody uses are the FunCube Pro Plus SDRs. And some stations use the cheaper RTL SDR dongles that we talked about during the Elmer session a little bit. So the antennas that we use right there, I've got the brands and the model number of what most of our stations that we're putting up consist of. The 70 centimeter antennas, the Laird YS4306s. Of course, those are small antennas compared to these larger ones made by a company up in Canada called Maple Leaf that receive transmissions at 166.380 megahertz. So those are the 2 frequencies that the tags transmit at. For cables at all of our stations, we're using these large gauge LMR 400 cables. And the reason we use those is really to reduce potential signal loss over long distances. Some of our stations, the antennas are mounted up on an antenna tower, a couple 100 feet into the air. And LMR 400 works well over that sort of distance. Of course, these need a power source as well. Sometimes we use solar power. Often I try to find a place that we can place them that has existing power on site. And then last but not least, how do we get the data from this to Motus's servers? These stations can transmit over the internet. Of course, they can send data to the server over the internet, but a couple of these have the ability to transmit through cellular connectivity as well. And that's one of the benefits of CTT's specific station, is it has the ability to have onboard cellular connectivity. So the other portion of the system are the tags. Here are two birds wearing the two different brands of tags. These are birds that we put tags on this summer up at Soapstone Prairie Natural Area, which is city of Fort Collins owned natural area north of Fort Collins, kind of along the Wyoming border. So the low-tech tags, like what you see on this lark bunting, the black bird with the white on its wings, that's our state bird, actually, the lark bunting. That low-tech tag, they transmit at 166.38 megahertz. And the CTT tags, what's on this grasshopper sparrow, transmit at the 434 megahertz. This tag itself is kind of interesting. If you look closely, it's kind of hard to see, I understand, but this one has a solar panel on board of the tag. And so this tag is called the life tag. You know, it should last the life of the bird. So I clicked, and of course you can't hear my audio, but what you would be hearing is the tag that we placed on that lark bunting. It's transmitting at that frequency, has a pulse rate of 25.1 seconds, and the battery on that thing makes it so that it can last about 400 days. The solar powered tag that's on that grasshopper sparrow does not have an onboard battery, so it only functions when there's sufficient light to power it from that solar panel. That causes some problems when we're trying to study lots of these, study some of these smaller bodied birds because they migrate at night. And so, you know, that's not extremely effective, but the tags that everybody's trying to make are these hybrid tags that have a battery and solar panel on them. What I've shown you, what I've brought up here is essentially what we're listening to. These tags all have coded transmission. They send out transmission at the exact same frequency, but they're coded micropulses. You can see that there's coded pulses microseconds apart. You can see in this picture here, this is a picture of 4 of those pulses, and they're quite close together, but far enough apart that when you pull them out with a computer, you can tell the difference between the different tags. So
Matt,
the tags from, I'm sorry.
Matt, are you using Chrome? What browser are you using?
I am using Chrome, yeah.
It says if you present using a Chrome tab, that it'll port the audio.
Okay, I'm presenting using a PowerPoint and
Yeah.
sharing my screen, and so that might make things difficult.
Okay.
But that's okay. I mean, all you would be hearing is a series of clicks. It's just clicks every 25 seconds. It's kind of boring. But these tags are as small as 0.15 grams, and so they can even be put on small-bodied things such as grasshoppers. They can be put on dragonflies and even monarch butterflies. Some researchers are following the migratory behavior of some of those insects using these same tags and this same system. So when you combine all of this, this is the sort of movement data that you can get. I'm going to show you a quick video here. All of these circles on this map you can see of the northeastern half of the continent are Motus receiver stations. You can see they're quite heavily based on that peninsula in Ontario, and that's simply because that's where Birds Canada is based itself. But there's quite a few here in the United States as well. So I've pushed play. These researchers tagged a bunch of different kinds of thrushes, Bicknell's thrushes, Swainson's thrushes, and gray-cheeked thrushes to follow them on their fall southward migration. And so the date is increasing slowly, and these birds are being detected by 1 or more stations. And the researchers are able to understand the specific routes that birds use using this technology. Here's another example. Let's see if I can go forward. My slide here. There we go. Here's another example where researchers tagged these same thrushes, but down in Colombia, the northern part of South America. And followed the birds as they moved north during their spring migration. And so these tracks that you're seeing are, you know, rough estimates. They're really just a line between each of the stations that picked them up. But it's important information because we can get, you know, the exact date that the birds left Colombia, and we can get, you know, the amount of time that they took to migrate from the northern part of South America to wherever they're received again. And this study in particular, where they tracked these birds moving from Colombia up into North America, taught us a lot about the migratory behaviors that these thrushes do. So they choose to fatten up on their stopover site right before they leave the northern part of Colombia and fly as far as they can without stopping. In fact, in some of these cases, these birds crossed the Caribbean and the Gulf of Mexico in less than 48 hours. They made that flight just directly. One of these birds was detected in Canada after leaving Colombia. It was detected in Canada just 3 days later. So if we were to calculate that, it was flying, you know, quite fast and using all of its energy just to get to its next destination as far as it possibly could north. So it's pretty interesting, the kinds of information, the kind of data that we can get using Motus. I'll just play that again so you can see it. That's the period between April 5th of 2016 to June 17th of 2016, and that's 37 birds moving. Sorry, I'm just trying to go forward on my presentation here. There we go. It's the problem of putting an animation in. So what we're looking at here is a map of North America. All these black dots are existing Motus receiver stations. You can see they're heavily placed out in the eastern half of the continent. And overlaid on top of this is a purple blob that is the Great Plains and Chihuahuan Desert region. So the region of interest, the geographic region of interest for Bird Conservancy studies. You can see within that region, there's not very many Motus stations existing right now, and that makes it quite difficult to answer some of the specific questions we're interested in. But we have plans to fill out this region. We received some funding from National Fish and Wildlife Foundation, U.S. Fish and Wildlife, and several contracts with Nature Conservancy as well, to begin to build out the network in this region. We've received enough funding to build 34 stations so far, and we have plans to build those over the next several years. So in order to get this work done, we're going to build off of existing partnerships that we have from our trinational work, researching grassland birds that we've done previous to this. We're going to work on developing some new partnerships and relationships with researchers who are already working within this region through conference presentations and webinars. We've now held 2 of our planning webinars. Our last one was just yesterday, where we've brought together researchers and other partners in this region to try to develop a prioritized plan of where we can place these stations and how we can move forward to get this region filled out in such a way that we can make it effectively usable for our research. We also plan to hold some Motus workshops. These are going to be workshops where we teach people hands-on about Motus and how to use it. These will probably be done during virtually because of COVID. We hope that we can do some of them in person, but we'll see how everything plays out with the situation. And then over the next several years, we'll continue to install these Motus stations as we're able to. What you're seeing here is a receiver station that I placed down in South Park at a private landowner's, just their home, just south of Fairplay. And this is a fairly simple station here. It really just has our, we're just tagging birds down here with the low-tech tags, and so it does not have the ability to receive the 70 centimeter band. But this has 3 Yagis, 3 of the directional antennas, and omnidirectional mounted at the top. So the Motus workshops that we're going to be holding will have partners and, oh, I think I just lost my presentation. That's bizarre. Apologize. Bear with me. I don't know how in the heck that happened.
Won't want a virtual session be without a technical difficulty, right?
Yeah, that's where we're at.
Quick
I've never had
question for you. What kind of range do you get in terms of the receiver sites picking up individual birds? What distance?
Yeah, we estimate that the range is about 12 to 15 kilometers. That has been shown in practice in some of the studies. Most researchers who are actually trying to measure the range of detection have only been able to detect nearby birds, so birds that are within a kilometer from that station. But some testing with these on not on birds, but placed on drones and other things show that at the 70 centimeter band, we're able to get detections 20 to 30 miles away from the station. And the 166 megahertz a little bit closer to the station from there, maybe 12 miles or so. But whenever we're asked that question, that is always, a question that researchers want to know is how far away do the birds have to be before I can detect them with our station? And that's always, you all know that radio is a difficult monster to exactly estimate a detection range. And I've gotten to where I don't tell them a range anymore. I just say, it's really difficult to say. Every single station is different. The topography, the vegetation of that nearby that station affects everything. So some testing shows that we can get, quite good distances with them, but in practice, that's always difficult to tell. The data that we get when a bird is detected is really just a timestamp and an ID for that tag. So it doesn't, and a signal strength, I'm sorry. So it doesn't give us any exact location specific information. But theoretically, if you have it detected on several of the antennas, you might be able to triangulate that using the signal strength. But in practice, that's a little bit difficult as well. So back to my presentation here. I was able to bring it back up and start where we left off. We will be hosting these Motus workshops across the Great Plains and Chihuahuan Desert region, where we bring partners together in a non-COVID world and give them some hands-on experience building an actual Motus station on site, putting all the antennas together, raising a tower, guying it down. And when I say raising a tower, it's 20 feet tall or something like that, not tall at all. Just a pop-up tripod or a tripod with a pop-up mast. Then people learn about, what equipment they need and how to maintain it. And also, importantly, they learn what not to do. These are all avian ecologists and ornithologists that we're bringing together to learn about radio and to learn about how to use radio in their research. And for many of them, for most of them, including myself, it's a very steep learning curve. The concepts involved are difficult if you're not savvy in the tech. So one of the interesting projects that we're going to be doing, funded by the U.S. Fish and Wildlife Service, is testing some of this equipment using drones. We've got a drone program here at Bird Conservancy that we use to study the changes in habitats using some imaging taken from the drone. We can measure changes in habitats, and so we're going to be using those drones, putting tags on them to learn about what we're trying to discuss, that detection range. And we understand that what we learn from one test is probably not going to translate well to every single station, but it might give us an idea of a rough idea of the ideal spacing that we should have between our stations here in the Great Plains. You know, a prairie is kind of an ideal place for radio because of the lack of topography and the lack of vegetation and such. But Motus really hasn't been done in a grassland before. We're interested to see what kinds of effects the vegetation, the grass cover itself, might have picking up birds. So we'll be placing, we have already placed these 2 stations, the one at Soapstone and the one at Rocky Mountain Arsenal Wildlife Refuge. And we'll be placing 4 more across northern Colorado, and we'll be doing this drone testing to try to get at that detection range idea. So the other 4 locations, we're working with National Ecological Observatory Network, NEON. They're based in Boulder. Battelle is the company that runs the NEON project. It's a National Science Foundation funded project to study climate change. 2 of their stations we hope to be able to place Motus receiver on. One at the Central Plains Experimental Range up on the Pawnee Grasslands, and another one out just east of Sterling. And then we hope to be able to place one nearby or on one of the workstations that they have on the grasslands itself, and then another one up at Arapahoe National Wildlife Refuge up in North Park. And I already described the drone testing that we're going to be doing. We'll also be placing tags on birds during this drone testing and see if we're able to pick up those birds at the same time. So here's a general timeline of what we plan to do to develop out this Great Plains and Chihuahuan Desert Motus network. Like I said, we're starting with these 34 funded stations. By early next year, we hope to have locations, specific locations chosen for these stations throughout the region somewhere. We have already installed 4 stations, 2 in Kansas and 2 here in Colorado. We have 4 more stations planned, those 4 just in northern Colorado I showed you. 8 of these stations are slated for installation down in Mexico in the Chihuahuan Desert, which leaves us with about 18 to be placed somewhere in the Great Plains. Yesterday on our planning webinar, we brought together our partners and got a rough outline or a rough idea of where we want to place those 18 stations. So over the next 2 years, we would like to install the remaining 30 stations. That's all of these that we have not installed. We're going to be hosting or holding some Motus workshops, whether it's virtual or in person. And throughout this time frame, we'll also be tagging about 200 grassland birds to begin to get at some of these questions, some of these research questions that we're interested in. Part of this initial funding that we obtained to begin this project also paid for about 200 tags. Throughout the next several years, we're also going to be looking for more funding opportunities to continue to fill in this network, both in the north and in the Chihuahuan Desert itself. And we hope within the next 3 or 4 years to be able to finish filling out this network with an adequate number of stations that we can get at the questions we're interested in. And we're doing this in a collaborative kind of manner. We're working with partners who already work throughout this region. We're working on not just grassland birds, but other birds that use the Great Plains and Chihuahuan Desert. There's shorebirds and all kinds of, there's raptors and all sorts of other birds that use this area. And we're working with them to identify specific locations that might benefit not just our research, but theirs as well. Because Motus is a very collaborative network. All of the data is centrally placed within the servers that Birds Canada owns and operates, and it's freely available to any of the researchers. When a bird is detected at my station, the other researchers will learn about that detection and vice versa. So from our planning meeting yesterday, this is just a Google map that we use for internal planning. we've decided that this area kind of on the north and south borders of Kansas will be where we place these 18 stations. It will be continuing some existing lines, these yellow dots on here. I know this is kind of difficult to look at. I apologize. I can't zoom in on it. These yellow dots are the existing stations, and we're going to be continuing some of the lines across both the southern border and northern border of Kansas, and really sort of drawing a line in the middle of the Great Plains and Chihuahuan Desert, and then working north and south from there. So some other interesting technology that is available that can be used with this same network, pardon me, are these nodes. This is a node right here in the middle. It's really just a small scale receiving station with a tiny antenna on it. It's an omnidirectional antenna. And this antenna will detect any tag within about 200 to 300 meters from that node. And so researchers are placing one receiving station centrally located or kind of on the edge, and then within a specific landscape that they're interested in researching, they're able to place a grid of these nodes across that landscape. And using the signal strength and the time stamp, the exact time stamp of detection of birds, really able to build a heat map of territory usage or landscape usage, so we can get some really fine scale movement and landscape usage studies done using these nodes. So that's kind of a neat little potential thing as well, and lots of researchers are starting to get into using these nodes. The station that you see on the left here, this is our station up at Soapstone. The small Yagi, that directional kind of coming off the end, that's connecting with the cell network. That's just aiming at the nearby cell tower so that I can boost the cell signal. But we have built this station in such a way that we can build a little grid of nodes on Soapstone Prairie Natural Area itself, because the city of Fort Collins has released some black-footed ferrets, an endangered species, a species we once thought was extinct. They've released some of those black-footed ferrets back out onto the property, and they want to study how these ferrets are using the property itself. And so they've got some plans in the future to put out one of these grids of nodes across the place where these ferrets are using Soapstone, and tag a few of the animals and follow them and learn really, what places on Soapstone are most important for the ferrets and such. So it's kind of a cool addition to what we can do with these Motus receivers. And so with that, that's really all I've got. I'm very happy to answer questions. Here's my email address, matt.webb@birdconservancy.org. Please email me if you're interested to talk more about this. And one of the reasons that I really wanted to speak at the Denver Radio Club meeting in particular was we really feel like this is an opportunity for bird research to meld with a community like the ham radio community. We feel like there's some, overlapping interests here. We're interested in finding locations where we can place these receivers, or other people who might be interested in collaborating with us in this kind of a way. And so, existing infrastructure is what we're interested in. Places that we can just simply add antennas and a receiver onto would be very nice. One of the things we don't want to do in the grasslands is just continue to erect a bunch more towers, because we know from previous studies that that predators use those towers. So raptors will use them as a perch to then be able to prey on those grassland birds that we're studying. We don't want to increase the likelihood that we will be, encouraging the kill off of a bunch of grassland birds that we're trying to work on conserving. So, learning more about existing infrastructure is something that I'm very, very interested in. These antennas don't need to be placed, extremely high because of the flat topography of the Great Plains, but I know some people are using some old windmills and things like that that might exist in a prairie already. So I'm interested to talk to anybody if they've got access to existing infrastructure, or know anybody, or connect me with somebody who might have a large network of towers and that kind of thing. So yeah, I'll stop talking, and please ask me questions that you might be interested in knowing more about. Thank you.
Hey, Matt, this is Jerry. I might have missed it some along the line here, but what does Motus stand for?
Motus is it's not an acronym. It's a Latin word for movement. And so it's kind of confusing to a lot of people, that it does look like an acronym, but it just means movement. So
Okay. That's what I was trying to figure out. Trying
yeah,
to get an acronym out of it. Yeah, okay.
Yeah.
Thank you.
Yep. And I'm going to leave my presentation on here so that you can see my email address just a little longer. But
Anybody else got a question for Matt?
Yeah, Matt, my name is Dave. My ham call is WG0N. And first of all, do you realize that your 70 centimeter frequency is in the ham radio band up there?
I just read about that. I had no idea. But yeah, that's very interesting. I just learned that.
Yeah, we have access from 420 to 450 megahertz, and we, as I recall, Jerry, correct me if I'm wrong, but we have secondary status in all or parts of that band. But the good thing is that many of our receivers and transmitters, we already have them for that band,
Nice.
and we talk in that 70 centimeter band. So that's something you might keep your ears open for too, because not only could some of us provide infrastructure, some tower equipment, but we already have some antennas that work up there.
Nice. Yeah, that's great. Yeah, I've noticed when I'm pricing these antennas for that band in particular that there are tons and tons available. And I imagine it is because of the ham radio community. So yeah.
Yes, sir.
I appreciate that. Yeah, and in that kind of a case, it might be a simple just adding even like one of those hand-built or home-built sensor gnomes to an existing station, and connecting with the data, collecting that data using your existing antennas as well. I don't know how hard or easy that might be, but that's something that comes to mind when we talk about that. So
sure. Thanks for your presentation. Appreciate it.
yeah, thank you.
Okay, anybody else? Going once, going twice. Well, Matt?
Yeah,
go ahead.
Yeah, hi, this is Jeff Deaton, N6BA. Hey, Matt, great presentation.
Thank you.
I guess a quick question, and maybe this is a little bit of an ignorant question, but as far as the infrastructure, software-wise and some of the small compute infrastructure, can sort of any schmo off the street, so to speak, build a sensor gnome and then plug into the Motus network and sort of help out? Is that a possibility, or are there licensing issues or regulatory issues or anything like that?
No, that is absolutely a possibility. Anybody could do that. I can provide plans on how to build them. I think Motus themselves, Birds Canada, they're in the process of putting together a website that describes sensor gnomes in detail. We used to have one, but we lost the server access or the hosting for that website, and so we're trying to rebuild that. But we plan to have videos and step-by-step guides and all that kind of built on how to create your own sensor gnome. But yeah, anybody could do it. Anybody can build their own sensor gnome, put it at your house, connect it to the Motus network, and be part of this. There are no fees associated with running a receiver station. the fees for Motus come from tagging the birds. So it's the researchers who are putting these tags on the birds who pay the fees to do the upkeep of the server. And Motus really did it that way. Birds Canada planned it that way so that anybody could get into hosting a station, because the more stations, the better for the network as a whole. So yeah, that's a great question. Thank you.
Matt, Bill, Inzer LAJ has a question in the chat. What is the RF power that is emitted by the transmitters on the Sparrows?
That is one that I don't know right off. I could probably find that or ask one of the companies, but at that point you might be able to find that yourself too by asking one of the companies' low-tech wireless or cellular tracking technologies. That's not something that I know about it. What would that power be? Would that be watts, I guess?
I think milliwatts probably, if it was watts.
Or microwatts if.
Microwatts, okay.
Yeah.
Yeah. We get our spec sheets and everything from the companies, and that's not something that they include in those spec sheets. Most likely because avian ecologists wouldn't know what that number means. but I'm sure that that information can be available from them.
What were the company names again?
Low-tech wireless is one, and cellular tracking technologies. What I could do is I could put their websites in the chat.
Matt, how do they catch these birds to tag them without, hurting them or anything else like that?
Yeah, so that's something that I've got a lot of experience with doing. We, as researchers, we've always been catching and banding birds. We catch birds in a mist net, so it's a really, really fine net with small holes, really, really fine nylon string, and it's loosely hung. And so when the birds are flying, they just kind of get tangled into it and fall into a loose pocket on the net itself. And then avian ecologists such as myself are trained to be able to come in and delicately remove that, untangle the bird from the net without injuring it. That takes a lot of training, and do it in a safe way. And we all have specific permits from U.S. Fish and Wildlife Service to be able to do this. It's not something that just anybody can catch birds, and so you have to be permitted and have lots and lots of training to do it. But in order to do a lot of our research, we have to have the birds in hand. Oftentimes, we might be doing research where we draw blood or where we attach a tracker of these kinds to a bird. And to do that, you might have to have the bird in hand. One of the benefits of the Motus Wildlife Tracking Network itself is that this is passive. You don't have to recapture the bird to collect the data. There are a lot of different kinds of trackers that are available, but the vast majority of them you have to recatch the bird and take the unit off of it to download the data that had collected for the previous year. And in an ecosystem such as a grassland, that might be next to impossible to recapture that same bird, even within the week that you caught it, because that bird may have moved away from that specific location where you caught it. In other ecosystems, such as people's backyards, where I've done a lot of banding in the past, and in a forested environment, birds use very specific and quite small territories, and we're able to target those birds by playing their song and bring them into the net and recapture them much easier. But with Motus, because the tag is transmitting from them, you don't have to recapture the bird to collect that data, so that's kind of nice.
Thank you. Anybody else got a question, comment? Matt, you might want to, maybe we could help you. It sounds like, the Denver area is really not what you're looking at, but there's some other clubs, that are in only Sterling and other places on that part of the world, Nebraska, Kansas.
Okay. Yeah.
That might be something that would, help you in a better location than Metro Denver.
Yeah, and I see in the chat there's a question from Chris Hamilton. What kind of host sites are we looking for? That kind of goes along with the same comment you were talking about. Anybody can host a site, and that site could be useful to us to study grassland birds, even in the city, because birds don't just fly over grasslands when they're migrating. They do pass over cities. We know that from other tracking studies, banding studies. People actually will go out at night into their backyards and listen to birds as they migrate over. And there are a lot of people here in Colorado who have recorders that, so like an automated recording system that is just recording the night sky every night during migration and feeding that into a computer where there's some software that will identify which birds that are flying over. And a lot of those recording systems inside of cities, even in Boulder and up in the mountains, show that grassland birds are using, are flying over these areas. So, a receiver station in the city would be interesting. It'd be interesting to know if some of our tagged birds are passing over Denver. And anybody, can participate. We don't need just towers on ranches, but people in cities and apartment dwellers could participate in this by having a receiver at your house.
Okay.
Yeah, I will definitely look into. I found the website ARRL, the Amateur Radio League,
Right.
and I will start reaching out to other radio clubs throughout the Great Plains as we start, working our way out into those areas. So.
Well, that should answer Chris's question, I think. Another of our members said, are hummingbirds part of the program?
Yeah, we here at Bird Conservancy don't specifically study hummingbirds. In Colorado, we have 2 species of hummingbirds most of the year. Sometimes we have 3, and depending on, migratory mistakes or something, we might have more hummingbirds that move in, in the different seasons. But we aren't specifically studying hummingbirds, but there are numerous people who are catching and banding hummingbirds throughout all of North America. I don't know of any specifically who are tagging hummingbirds with these Motus tags. The smallest tags being 0.15 grams, that still is quite a percentage of a hummingbird's body weight. And based on our research permits that we hold from U.S. Fish and Wildlife Service, we can only attach anything to a bird up to 3% of its body weight. And so if we're talking about a hummingbird that weighs, 1.5 grams, 0.15 grams is 10% already of its body weight, so.
How far do hummingbirds migrate, and what's their life expectancy?
So hummingbirds migrate pretty far. I mean, from banding data, we know that they migrate down into Central and South America from North America here. So the birds that breed here in the Western United States spend their winter down in Central and South America. Over in the East, I know that a lot of the ruby-throated hummingbirds, that's the species of hummingbird found in the East, they cross the Gulf of Mexico. And often they do that in one flight. And if you can imagine, the size of these birds being pushed around by potentially even hurricanes during their fall migration, but a lot of the oil rigs and boats and things in the Gulf, oftentimes during migration, are covered with birds that are just extremely tired. They'll stop and land on those oil rigs and on those boats and just rest up and then take off again the next morning or something. And so, they do fly extremely long distances. And hummingbirds, from banding data, they typically live, 3 years, 4 years, something like that. I don't know the longest lived, the record, but I would imagine 7 to 9 years might not be too unexpected for a hummingbird lifespan. But that's extremely interesting and also crazy to think about, because a hummingbird is always living right on the edge of its survival. It's always hungry, it's always just like burning up as much of its energy and trying to feed as much at the same time. So they're just kind of living on the edge. And a lot of these birds, a lot of these small-bodied birds, the sparrows and the grasshopper sparrows, lark buntings, these grassland birds are also sort of living along that same kind of thing, just right on the edge, just trying to feed as much as possible, trying to get to where they breed, and then get back to where they're where the food source is before they freeze to death up here. So yeah, studying birds is very interesting, and I also learned that the more we learn about birds, the less we know. The more that technologies like Motus here and other kinds of tracking technologies open up the ability to research birds, the less that we know. We learn that we don't know a lot about them. So, yeah.
So I looked over the spec sheets on both the low tech and the other side, and they state the operating frequencies and the temperature ranges. They don't state the RF output.
Yeah, I could reach out to some researchers, or I'm sorry, to the my contacts at those companies and find out if they would tell me that information. But yeah, I'm not entirely certain.
All righty. Any other questions for Matt? I don't see anything else on the chat, so we thank you. Very interesting. Very interesting. So, like I say, if we can, maybe we can help you, make some, well, like Chris was saying there, he sounds like he may be interested in, put up a station, and with the Raspberry Pi, stuff that's available, you have to somehow modem into your internet, I guess, to send the data. So, but that's pretty common with everything nowadays. So
yeah, yeah, and the data is collected on an SD card on board as well, and that could easily just be downloaded and then uploaded to the Motus website if there is no internet connection. So
that'd be easy enough.
Yeah, it is. Yeah, and if you are interested in building one of these, please let me know. Get a hold of me at my email address there, and I could show you how to build one. We can show you how to place this on the Motus website so that it then becomes part of the network too. That metadata of putting the station on the website is extremely important for this network to work too. So
maybe what we can do is get with you and get some of that how-to, and maybe we could put a splash in our roundtable, our club newspaper.
Yeah.
And also, well, we've got probably the newspaper. We've got our web page too, but we could put something on there. We're always looking for interesting things to put out, and maybe get a couple takers here. So
yeah, that would be really great. That would be amazing.
Good deal.
Awesome.
Okay.
Great.
Any final questions?
Matt, thank you, and we hope that you'd entertain joining the club and continue to attend our monthly meetings.
Yeah. I mean, the more that I do this, like I was saying, I'm getting more and more interested in what ham radio is, and all of the different things. I'm really interested in trying to build my own antennas to try to keep costs down as well. So it seems like the perfect club to be talking about this kind of thing. So yeah, I appreciate the opportunity to come here, and I do look forward to future meetings too. Thank you.
Well, that is one thing with those antennas. They could be built, of course, a lot cheaper, and you can buy them. So that's another avenue too. So we'll keep in touch and see what we can help you with.
Okay, great.
Okay,
I
with
appreciate
that,
the time.
okay, we'll say thanks, and
All right.
I guess that's it for tonight. Thanks everybody for joining up, and we'll see you the next program. Thank you, everybody.
Great. Thank you. Bye-bye.